NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve a special case floor equation of the form left bracket ax right bracket plus b left bracket x right bracket plus c equals 0. We will follow a clear 4-step algorithm. First, let's show the example label and the problem statement. Step 1. We split x into its integer and fractional parts. We write x equals n plus p, with p between 0 inclusive and 1 exclusive, and n an integer. It's helpful to picture the interval for p on a number line from 0 to 1. Step 2. We analyze the floor of a p that appears inside left bracket ax right bracket. Since ax equals a times n plus a times p, and p lies between 0 and 1, the product ap lies between 0 and a. That means the floor of ap can be any integer from 0 up to a minus 1. We'll represent those possible values as k equals 0, 1, up to a minus 1. Step 3. We substitute x equals n plus p back into the original equation. Start with left bracket a, n plus p, right bracket plus b times left bracket n plus p, right bracket plus c equals 0. Because an and n are integers, they come out of the floor. And since p is between 0 and 1, the floor of p equals 0. Therefore, the equation becomes n times a plus b plus left bracket ap right bracket plus c equals 0. Step 4. Solve for the integer part, n. We isolate n to get n times a plus b equals negative c plus left bracket ap right bracket. So n equals negative c plus left bracket ap right bracket divided by a plus b. For n to be an integer, a plus b must divide c plus left bracket ap right bracket exactly. Special cases. If a plus b equals 0 and negative c plus left bracket ap right bracket is not 0, there is no solution. If a plus b equals 0 and negative c plus left bracket ap right bracket equals 0, there are infinitely many solutions along the valid p range. Finally, for each choice k equals left bracket ap right bracket, p must lie between k over a and k plus 1 over a, and the solutions are x equals n plus p within that interval. Let's put the algorithm together in one picture. Choose k from 0 up to a minus 1. Check the divisibility condition. If it holds, compute n. Then p is between k over a and k plus 1 over a. The solution is x equals n plus p in that interval. Final answer. For each integer k from 0 to a minus 1, such that a plus b divides c plus k, we have n equals negative c plus k over a plus b, p between k over a and k plus 1 over a, and x equals n plus p in that interval. In this lesson, we will solve the floor function equation, open bracket 2x close bracket minus open bracket x close bracket plus 3 equals 0, using a structured algorithm with x written as n plus p. First, let's place the problem statement on screen and highlight the plan. Any real number x can be written uniquely as n plus p, where n is the integer part or floor of x, and p is the fractional part between 0 inclusive and 1 exclusive. We'll use this to turn the floor terms into expressions in terms of n and p. The algorithm for equations of the form a times open bracket x close bracket plus b times open bracket x close bracket plus c equals 0 yields a formula for n. In our case, at equals 2, b equals negative 1, and c equals 3. The derived formula gives n equals negative of c plus floor of ap, all over a plus b, substituting at equals 2, b equals negative 1, and c equals 3 gives n equals negative of 3 plus floor of 2p, over 1, which simplifies to n equals negative of 3 plus floor of 2p. Because p is between 0 inclusive and 1 exclusive, 2p is between 0 and 2, which means the floor of 2p can only be 0 or 1. We evaluate two cases. Case 1, if floor of 2p equals 0, then n equals negative 3, which implies x is between negative 3 and negative 2. Case 2, if floor of 2p equals 1, then n equals negative 4, which implies x is between negative 4 and negative 3. Let's place these intervals on a number line to see the union clearly. We will draw in interval notation. X is in the interval left bracket negative 4 comma negative 2 parenthesis. In this lesson, we will solve the floor equation. Open bracket 2x close bracket equals 2 times open bracket x close bracket. We will follow the specific 4-step algorithm exactly as written. Step 1. Set the equation to 0 by moving all terms to one side. We get open bracket 2x close bracket minus 2 times open bracket x close bracket equals 0. Step 2. Use the general substitution x equals n plus p, where n is an integer equal to the floor of x, and p is the fractional part with 0 less than or equal to p less than 1. The algorithm states a constant rule for equations of the form a times open bracket qx close bracket plus b times open bracket x close bracket equals c. Here, the constants are equals 2, b equals -2, and c equals 0. Plugging into n equals negative of c plus open bracket, a p close bracket divided by a plus b, we get n equals negative open bracket 2p close bracket over 2 minus 2, which is n equals negative open bracket 2p close bracket over 0. Since division by 0 is undefined, we must analyze the numerator term open bracket 2p close bracket by cases. Step 3. Analyze the possible values of open bracket 2p close bracket. Because 0 is less than or equal to p and p is less than 1 and p is less than 1, 2p is at least 0 and less than 2. Therefore, open bracket 2p close bracket can only be 0 or 1. Case 1. If open bracket 2p close bracket equals 0, then n equals 0 over 0 in the formula, which means the equation is an identity in n within this case, so solutions exist. Case 2. If open bracket 2p close bracket equals 1, then n equals -1 over 0, which yields no solution. Therefore, the equation has solutions only when open bracket 2p close bracket equals 0. Step 4. Solve the condition open bracket 2p close bracket equals 0 for p, and then for x. Open bracket 2p close bracket equals 0 means 0 is less than or equal to 2p and 2p is less than 1. Divide by 2 to get 0 less than or equal to p and p is less than 1/2. Since x equals n plus p, adding n to this inequality yields n less than or equal to x, and x is less than n plus 1/2 for any integer n. So the solution set is the union over all integers n of the half intervals from n to n plus 1/2. To build intuition, let us visualize the solution on a number line. Each green segment shows the values of x that satisfy the equation on one integer block. Notice the pattern repeats every integer. From n to n plus 1/2 is included, and from n plus 1/2 to n plus 1 is excluded. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.